Our topic today will be exoplanets. Exoplanets are much further from the Earth than solar system planets. For example, the nearest exoplanet is Proxima Centauri b, which is 4.24 light-years away from the Earth. For comparison, Neptune is 4.34 billion kilometers away from the Earth. A light-year is the distance traveled by light in 1 year, which equals 9.5 trillion kilometers. Which means that Proxima Centauri b is about 9.3 thousand times further away from the Earth than Neptune. In addition to being much further away from the Earth than solar system planets, exoplanets are mostly much smaller than stars. Also, exoplanets are often overglared by their star. These factors make exoplanets extremely hard to image directly. Thus there are only direct images of a couple tens of exoplanets. So, how are exoplanets discovered? There are several ways to discover an exoplanet. In this video, we are going to cover 3. They are radial velocity, transit, and direct imaging. First, let's talk about radial velocity. Planets orbit stars, but planets also have gravity. This causes their stars to wobble a little bit while the planets orbit. However, this wobble is not as intense as shown in the video. Radial velocity detects the star's speed relative to the Earth. But how? First, let's speak about the Doppler effect. The Doppler effect is a change in the frequency of a wave when the wave source is moving relative to the observer. Stars emit waves in the form of light, and a change in the frequency of light waves is seen as a change in light color. High-frequency visible light waves are blue, while low-frequency visible light waves are red. The star's wobble caused by the planet's gravity causes its relative angle of motion to the Earth to change. So, when the star is relatively moving towards the Earth, its lights are shifted towards the blue wavelength. And when the star is moving away from the Earth, its lights are shifted towards the red wavelength. Powerful telescopes can detect this, and thus it is known that the star has an exoplanet. Radial velocity is also known as Doppler spectroscopy. Some exoplanets discovered using radial velocity include 51 Pegasi b, Pollux b, and Gliese 581e. Next, we will speak about transit. Transit is a method used to detect exoplanets which pass in front of their host star from Earth's point of view. An event where a planet passes in front of its host star is known as a transit. When an exoplanet transits its star, this causes the star to become slightly dimmer because the exoplanet hides some of its light. Powerful telescopes can detect this. Thus, the exoplanet is discovered. Transit was the method of detection used by the famous Kepler Space Telescope. Out of 5,785 known exoplanets, 4,303 exoplanets have been discovered using transit. Some examples of planets detected using transit include Corot 8b, Kepler 22b, and Kepler 42b. And lastly, let's speak about direct imaging. The images of exoplanets like these ones are not real images. Instead, real images look something more like this. In direct imaging, a telescope basically detects the light coming from a planet. Some planets discovered using direct imaging include Beta Pictoris b, 51 Eridani b, and Ophiuchi 11b. Other methods of exoplanet detection include microlensing, astrometry, pulsar timing, and transit timing. And we reached the end of the video. Bye! See you next time!